In this video, we will be discussing the limit of a given function while applying the limit of special functions. So on the screen, we have three colors of functions, limit of a function. So let's start with the blue one. It is the limit of sine x over x as x approaches 0 is equal to 1. So substituting the value of 0 in our function, it will become sine of 0 over 0. And sine of 0 is 0 over 0, which is indeterminate. But if you are going to simplify sine x over x and take its limit, we could have it equal to 1. While the red one is the limit of 1 minus cosine x over x as x approaches 0 is equal to 1. So if you are going to substitute the value of x in our function, it will become 1 minus cosine 0 over 0. And that is 1 minus cosine 0 is 1 over 0. And the numerator is 0 over the denominator is 0. Again, by mathematical procedures, when we take the limit of this function as x approaches 0, it will become equal to 0. Now for the green one, we have the limit of e raised to x minus 1 over x as x approaches 0. If we're going to check or substitute the value of 0 in our function, it will become e raised to 0 minus 1 over 0. And then simplifying it further, we have 1 minus 1 over 0. The numerator is already 0 and the denominator is 0. So this is indeterminate also. Indeterminate. But when we simplify the function and take its limit, it is equal to 1. We know that taking the limit of an indeterminate function is a discontinuity, is an example of discontinuity, but we can still reduce the function, simplify the function to make this discontinued function becomes continuous. Let us have an example. So number 1, we have the limit of x over sine x plus e raised to x as x approaches 0. So we know that the limit of the function here of sine x over x is equal to 1. Now, if you are going to reciprocate this value, then we can also reciprocate the limit. Now, the reciprocal of the limit or the reciprocal of 1 is still 1, meaning if we are going to reciprocate sine x over x and becomes x over sine x, the limit is going to be equal to 1 also, meaning as we rewrite this as the limit of x over sine x as x approaches 0 plus the limit of e raised to x as x approaches 0, the value of this function is already equal to 1, while the limit of e raised to 0 as x approaches 0 is also equal to 1. So this is going to be 1 plus 1 equal to 2. Example number 2, we have the limit of tangent of negative x over x as x approaches 0. In this example, we will be using a trigonometric function to simplify that negative x in our tangent. So it will become the limit of tangent of negative x is the same as negative tangent x, so over x as x approaches 0. But we cannot have these three functions. We have to produce these three functions in order to further simplify negative tangent x over x. So it could be written also as the limit of negative sine x over cosine x by ratio identity of tangent x over x as x approaches 0. Further simplifying this, it will become, so we have to take the reciprocal of our x in our denominator here. It will become the limit of negative sine x over cosine x times the reciprocal of x is 1 over x as x approaches 0. Now, we have this factors b equal to 1, meaning we can rewrite this whole function as the limit of 1 over cosine x times, negative 1 times sine x over x as x approaches 0. We already know that this is already equal to 1. Therefore, we can multiply this 1 to our negative 1 over cosine x, and will still give us negative 1 over cosine x. Now, substituting the value of x as 0, it will become negative 1 over cosine 0. And cosine 0 is equal to 1. So we have negative 1 over 1 is equal to negative 1. So we have example number 3. The limit of negative cosecant 3x over 2 over 3x as x approaches 0. So as you can see in this function, we cannot see any of these three special functions here: the blue, the red, and the green. So what are we going to do is to simplify this function, use trigonometric identities to produce one of the three special functions. So let's start with negative cosecant. So negative cosecant, cosecant x is the same as 1 over sine x. So taking or simplifying the function will become the limit of negative 1 over sine of 3x. So that's the reciprocal identity of cosecant 3x over 2 over 3x. And then we have x approaching 0. So let's further simplify this. It will become the limit of negative 1 over sine 3x times the reciprocal of the denominator, which is 3x, over 2 as x approaches 0. So this is already equal to 1. That's 3x over sine 3x is equal to 1, meaning we are being left with the limit of negative 1 over 2 as x approaches 0, and the limit of a constant is still a constant, meaning the final answer here is negative 1/2. Example number 4, we have the limit of e raised to sine x minus 1 over sine of negative x as x approaches 0. In this function, as you can see, the exponent of e is sine x, meaning we have to produce sine x also in our denominator. However, we have sine of negative x in the denominator. To produce sine x in the denominator or remove that negative, we can use the odd-even identity to simplify this sine of negative x in the denominator. So applying this odd-even identity of sine, it will become the limit of e raised to sine x minus 1 over negative sine x as x approaches 0. Why do we have to produce the same function in our denominator? Because in our function here, as you can see, our exponent in the numerator must be the same as the function in the denominator. So it must be the same. Well, in this case, they are already the same. We have this sine x in the exponent and sine x in our denominator, meaning the value of e raised to sine x, the value of e raised to sine x minus 1 over sine x is already equal to 1. So we have 1 over negative 1. Then the final answer, as we take the limit as x approaches 0, is equal to negative 1. Okay, for example number 5, we have the limit of tangent of negative x over 4x secant of negative x as x approaches 0. We cannot see any special function in this example, so we have to produce one, or even if possible, we can produce them all, and it will be easier for us to simplify the function and take its limit as x approaches 0. But let's see. So we have tangent of negative x. We can rewrite this as negative of tangent x using the odd even identity. So we could say that the limit of tangent x is the same as negative tangent x over 4x. And we have to produce, we do not have secant in our special functions, meaning we have to do some sort of identities, and I think we can substitute secant negative x as 1 over cosine of negative x. And then as x approaches 0, so further simplify this, we can rewrite, so we have the limit of negative tangent, and tangent can be written as sine x over cosine x. Why? Because there's no tangent x in our functions, in our 3 special functions. So we have to remove the tangent and change it to probably cosine or sine. And then over 4x times 1 over cosine x. Now we have to simplify the denominator. We have to multiply 4x to 1 over cosine x. It will become the limit of negative sine x over cosine x all over 4x over cosine x as x approaches 0. And then we can simplify the function by taking the reciprocal of the denominator and multiply to the numerator. It will become the limit of negative sine x over cosine x times cosine x over 4x. As x approaches 0, we can see that we have to cancel cosine. So the remaining function will become the limit of negative sine x over 4x. As x approaches 0, taking the limit of sine x over x, sine x over x as x approaches 0 is equal to 1, meaning the final answer here is negative 1 over 4. Number 6, we have the limit of e raised to tangent x over 1 over sine e over e raised to sine x minus 1 as x approaches 0. So this is, I think we can apply the third special function, this function. So we have, if we are going to reciprocate this function like x over e raised to x minus 1, it is still equal to 1, because reciprocating it will make it equal to 1, and the reciprocal of 1 is 1 over 1, and taking its reciprocal, meaning the reciprocal of e raised to x minus 1 over x, which is x over e raised to x minus 1, is the same as equal to 1. So let's apply it here. In this example, we need tangent in the denominator because we have tangent as the exponent of our numerator. Now, in terms of the denominator now, like we have an exponent of sine x, we have to produce sine x in the numerator. So further simplifying this, it will become the limit of e raised to tangent x minus 1 over e raised to sine x minus 1 is to be multiplied by probably 1 and another 1 as x approaches 0. Now why am I going to multiply 2 1s to this function? Because I want to deform 1 wherein the function will be not affected by the balancer, our 1, because we have to produce sine and to produce tangent. So we have the limit of e raised to tangent x minus 1 over e raised to sine x minus 1 as x approaches 0. Now I want to deform my first one as tangent x over tangent x. Tangent x over tangent x is equal to 1. Now times my another one, I am going to deform it as sine x over sine x. Why? In terms of sine, I need sine in my numerator to partner it with my denominator. And for tangent, I need it to partner with my numerator. So I can rewrite this, since these are all factors. I can just rewrite this as the limit of e raised to tangent x minus 1 over tangent. So I have already used this and this one times sine x over e raised to sine x minus 1. So I have already used this sine and this denominator. Now the third factor will be tangent x over sine x as x approaches 0. Now I know that by special function, these two functions are already equal to 1. So meaning I have the limit of 1 times 1 times tangent x over sine x as x approaches 0. Now I still have tangent here. I have to remove that because there's no tangent in my function, and it will still become equal to an indeterminate value. Why? Okay, so let me explain. 1 times 1 is 1. Multiplying it by tangent x over sine x will give us tangent x over sine x. Now x is approaching 0. As we substitute 0 in our tangent and our sine, it is 0 over 0. It's indeterminate, meaning we can still simplify the function. So let's simplify the function using trigonometric identities. Our tangent is the same as sine x over cosine x over my sine x in the denominator as x approaches 0. Now, taking the reciprocal of our denominator, we have the limit of sine x over cosine x, and the denominator is sine x. Its reciprocal is 1 over sine x as x approaches 0. We can cancel it out now. So what we have is the limit of 1 over cosine x as x approaches 0. Now my x is equal to 0. I can change it to 0 in our cosine x. So the limit of 1 over... No. It will become 1 over cosine 0. And that is equal to 1 over 1 or 1. Now let's take a look at this example. We have the limit of 4 over x cosecant x plus 4 minus 4 cosine x over 3x as x approaches 0. Now, since cosecant for the first term, since cosecant is not in our special function, we can change it to sine. And there is a cosine here. I think we can manipulate the second term in order to produce the second special function. So let's start. We have the limit of 4 over x, and this is cosecant by trigonometric identity is the same as 1 over sine x plus the common factor of the second term. The common factor of this numerator is 4. The first term and the second term have 4. So we have 4. You have to factor it out. It will become 1 minus cosine x over 3x as x approaches 0. Now we can simplify the first term. This first term, it will become the limit of 4 times the reciprocal of our denominator. The denominator is going to be x over sine x, so the reciprocal will be sine x over x plus, that's 4/3. I am going to separate 4/3 as one factor because I want to regroup 1 minus cosine x over x, because 1 minus cosine x over x is a special function equal to 0 as x approaches 0. So let's simplify this further. It will become, I know that the limit of this function is 1. The limit of this function is 0. So I have 4 times 1 plus 4/3 times 0. So my final answer should be 4 plus 0 equal to 4. So we have example number 8. The limit of 2 tangent 3x cosine 3x over 3x plus 1 minus 3x minus cosine x over x as x approaches 0. It looks like a very complex example, but let us look at the solution if it is not. So tangent is not part of our special function. We can change it to a ratio identity sine x over cosine x. So the limit of 2, our tangent is sine x over cosine x times, 3x, because we have 3x here, times cosine 3x over, the denominator is 3x, plus, now in this second term, we only have one denominator, but I can see a sort of a second special function, 1 minus cosine x over x. So I am going to distribute x in each term of my numerator so that I could see which of the terms I might probably combine in order to produce the second special function. 1 over x minus 3x over x minus cosine x over x as x approaches 0. Now, to continue this solution, let's focus first on this first term, the trigonometric term here. So we have the limit as x approaches 0 of the function. I can cancel this out by division. It will become 1. So we have 2 sine of 3x. Probably times 1, multiplying this by 1 is the same as this 2 sine 3x. So I am not going to write it anymore. Over 3x. Now for the second term, here, we have 3 more terms. I think I can combine my first term here and my third term as one, because number 1, they have the same denominator. I can combine the numerator and write one denominator. So plus 1 minus cosine x over x. Okay, and I believe this whole value here is already equal to 0. So let's further simplify this. It will become the limit of, as x approaches 0, of the function 2 sine 3x over 3x. This is minus 3 and minus 1 plus 1 minus cosine x over x. I can now take the limit of each term. I have 3 terms here. The limit of this function is 1. So I have 2 times 1. The limit of negative 3 is still negative 3. And the limit of this whole function is 0. So plus 0. So I have 2 minus 3 plus 0 is equal to negative 1. Let us have the last example. We have the limit of 2 plus sine x minus 2 cosine x minus sine x cosine x over x squared plus 2x minus sine of negative 4x over 3x as x approaches 0. Well, I think when we substitute 0 here, it will become indeterminate. So what we're going to do here is to probably simplify the numerator of our first term and also the denominator of our first term, and then apply some sort of identity here in our second term. So let's start. I believe it is better to regroup first the numerator of the first term. I can see 2 here and 2 here, so I am going to write them following the other one. So we have 2 minus 2 cosine x. And then I have my sine here and sine. It is a common factor between these two terms. So we have plus sine x minus sine x cosine x. So what am I going to do is to factor it out later by using factoring by grouping. While the denominator can be factored out already, and the common factor is x. Both terms have x's, so we have x and x plus 2. Now, for the second term, minus, my sine of negative 4x here can be written as negative sine of 4x by odd-even identity over 3x. So this is going to be the whole function that we are going to simplify. Okay, so let me just rewrite the limit as x approaches 0. Okay, we're not yet done. So the numerator of the first term here can be factored out using factoring by grouping, and it will become the common factor of these two terms is 2. So we have 2, and the remaining factor is 1 minus cosine x. So let me check. 2 times 1, 2, and negative 2 times negative cosine x is negative 2 cosine x. While these two terms have a common factor, which is sine x. So let me factor out sine x. So plus sine x times what we left in our what we have in our second factor will be 1 minus cosine x. So as you can see, 1 times sine x is sine x here, and negative cosine x times sine x is negative sine x cosine x over x and x plus 2 minus plus, that's negative times negative is positive. We can multiply this sine 4x over 3x by 4 so that we could combine sine 4x and 4 as equal to 1. So let's do this further. With further solution, it will become the limit as x approaches 0 of the function. This numerator has a common factor, and the common factor is 1 minus cosine x and 1 minus cosine x. So I have to move it out, and the remaining factor, the other factor, will become, so this is the factored out 1 minus cosine x, and the remaining factor will be 2 plus sine x, 2 plus sine x. There you go. Over x times x plus 2. Now what we have here on the other side will become plus 4 sine 4x over 4. Over 3 times 4x. The numerator and denominator, and numerators, both of these two values are now balanced. So let's simplify this further. I think we have this equal to, the limit of this is equal to 0, and the limit of this is equal to 1. So I can rewrite this as 0 times 2 plus sine x over x plus 2 plus 4/3 times 1. And any number multiplied by 0 is 0. So this first term will become 0. And any number multiplied by 1 is the same as the number plus 4/3. Therefore, the answer is 0 plus 4/3, 4/3.